Static route is the only manual routing protocol in the world of routing protocols. And by manual, I mean this is my router and I'm connected to it, and it's connected to this one and this one, and after that maybe it's connected back to this router that is connected to this switch, that maybe this switch has 3 different VLANs. So virtually, since these are virtual LANs, these has maybe 3, let's say 2. Okay, 2 networks. Here there are 2 broadcast domains, maybe the 10 dot something and the 11 dot something, and my IP address is 192.168 dot something. In static route, this is the only routing protocol that you will manually, and you must manually tell your router and all these routers. This is the annoying thing about static routes, that you must access and configure all the routers for the same thing, going and backward. Of that, whenever I want to reach 10 dot something network, then you will take your packet first to this router, and I will access to this router and configure that if someone wants to get to 10 dot something, then please forward it to this network. After that, this router will already know how to connect to 10 dot something. And for 11, the 11 subnet, I must configure it by myself. Maybe if I want to route it to this router, then I will access this router to route it to this router, and this one will deliver me to the subnet 11. But you know, whenever there is a request, then there must be a reply. So I must inform this router that if anyone wanted to reach me, then please route it either from this way or from this way. This depends on how I want to make it. Maybe I can do something that's called load balancing, by making the router to send one packet from this path and the other one from this path. Okay, so half of the traffic will go down and the other half will go up from this path. Okay, this is an option that we can do in static route, but the idea is that this is the only routing protocol that you must by yourself do configure all these routers about how to forward and forward back or backward some packets to some destinations and using which path. There are no automatic or dynamic decisions taken by the protocol. Okay, that's what makes the metric of this is the algorithm or the criteria of choosing the path. The metric of the static route is 0, because there is no metric, there is no criteria of choosing the path. You do choose the path. The engineer is the one who is responsible for routing the packet all the way, starting from the first router up to the last router, even if there were like 50 router in the path. Okay, you must route it all the way, access all the devices and route it by yourself one by one. And you might get a mistake, you might cause some routing loop, because maybe you get confused at the end and there is maybe some link in here, and when you reach it this way, maybe by accidentally you re-mention the packet to be forwarded this way, so the packet will go at this loop. So some problems will happen in static route. There is no loop prevention mechanism, there is no route or path selection mechanism. It's very beneficial, the static route, in some scenarios, but mostly you will see that networks do relies on dynamic routing protocols. Okay, so 2 things are very important to know about every single routing protocol in the routing protocols world, is that you must know the administrative distance and the metric of every router. I have mentioned in the last video that the administrative distance of static route equals 1, and now I have said that there is no metric to choose the path, so the metric will be 0 for static route. Okay, so let's take this away. the only method to manually routing a specific packet to a specific route. The first next hop can either be the egress interface port ID or the next reachable IP address. This will be seen in the lab. What I mean is that to make the router understand that I want to route maybe 10 dot something using this path, then it's either I tell him route 10 dot something to the IP address of this interface. Maybe this interface has the IP address of 192.168.1.2 and this interface has 192.168.1.1. you will see this in the lab. Okay, so I will tell this router whenever someone wanted you to route a packet to subnet 10 to reach subnet 10 dot something, then just throw this packet to the IP address of 192.168.1.2 and this IP address will be the IP address of this router, this port of this router that is facing me, and inside this router I will tell him route 10.10. something to the IP address of this router. Okay, then it will reach the destination. Okay, the next IP address reachable, or the egress interface port ID. Maybe I will tell him route 10 dot something to fast ethernet 02, which is this one. Okay, so the packet will egress from fast ethernet 02, and okay, that's known, it's guaranteed that it will reach this interface. After that I will tell him also you route to 10 maybe fast ethernet 0.1, which will be this one, and then the packet will egress from this one, from this specific interface to reach the destination. So it's either I use the egress interface port ID or the next reachable IP address of the next router that's directly connected to me. Actually, I don't know why, but maybe in 90% of the cases, this second method is used of the next reachable IP address. So we'll type IP route this subnet to this IP address. Okay, you'll rarely see to the egress interface port. It will be to this IP address. Okay, so it's available for both IPv4 and IPv6. We will take the lab of both of them. It can route either a host or an entire network. In the previous video we have talked about the longest match prefix. So you can route something to subnet 24, which is a network, to subnet 28, which is a network, or to subnet 32, which by this will become subnet mask 32. This is not a network because subnet mask 32 is only for hosts. So you either tell the router to route something to host such IP/32 or to route a prefix maybe to a network which will be an IP/24. Okay, so we will see in the lab in case we have applied both of the scenarios. And there are lastly something we don't have a lot of talk about the static route. Lastly, we will talk about the flavors. There are two subtypes of the static route. The first one will be the default route. Default route will be something very important in what's called the gateway or in the upload direction or to the internet direction. What do I mean by this? I mean that this is the router of my network and it's connected to a switch. This switch is connected to the employees maybe of the company and some cameras and some printers and servers, etc. Okay, at the same time it's connected to another department in the company with all its employees and end devices. What I need internally in my network is to mention inside the routing table that in case someone wanted to reach this network, then please forward the packet to this interface, and in case someone wanted to reach this network, then please forward the packet to this interface. Okay, maybe there is a third network that's only for servers, a switch that is connected to only some servers. Okay, whenever some employee or any employee needed to go to the server for some service, then please route the packet this way. Okay, so there will be a lot of mentioning, maybe route some host for this specific path and route some network, route the network of the servers. A lot of things can be mentioned in the routing table, but I cannot mention the internet. because if those employees were allowed to reach the internet, maybe they want to reach Cisco.com, or maybe they wanted to reach youtube.com to check our channel and maybe study the CCNA course with us, okay, then they will need internet, and this is not something in my network, this is beyond my network. Okay, so I must mention the IP address and the next hop for Cisco.com. I must mention the IP address and next hop for YouTube, and maybe for Google.com, maybe for Facebook.com, maybe for Twitter.com, and so on. And you know that there are tens of thousands of websites around the world. So this is not acceptable to be all of them mentioned in the routing table, okay, because just for to you know that every platform, every hardware of router, every model of a router has some specifications in the datasheet of this specific router, and each model or each software version, maybe it depends on the route, the RP of the router, okay, with each one of them, the routing process, each one of them will have some specific lines of routes to be mentioned, to be allowed to be mentioned in the routing table. Okay, what I mean is that some routers do accept only 100 route to be installed in the routing table, others will accept 1000, others will very strong will accept maybe 10,000 route. Okay, so even if I can mention 10,000 routes in my routing table, this will cause absolutely to increase the utilization of the CPU and RAM. This is the first thing. The other thing is that the entire internet of the world is not 10,000 IP address, it's much more, so it will definitely not be beneficial or something really useful to mention all the websites in my routing table. What I will do is that I will apply default route. Default route is that when I apply default route to my router, what will default route do is that whenever someone wanted to reach an IP address that it is not mentioned in the routing table, sorry, for whatever reason is that, it's just that when my router check its routing table and sees that someone wants to reach the public IP address of 5.5.5.5 and this IP address is not installed in the routing table, then the default route will take the packet and forward it to the destination that I will specify. Okay, so in the default route, I do not specify or I do not advertise routes. I just say tell the router or confirm to the router that whenever you receive a route with an unknown destination because it's not installed in the routing table, then please forward it to this interface and maybe to fast Ethernet 04, and this interface will be the one going to the internet. Okay, so problem solved by using default route, because when someone wants to open Cisco.com and it's not installed in here, the packet will go to the router asking for the destination of the IP address of Cisco and Cisco.com, and it's not installed in my routing table. Then the router will say, I have no other choice but to use the default route, and I will send you through Fast Ethernet 04 because default route is applied on Fast Ethernet 04. Okay, the config of default route is only one single command that we will see in the lab section. Okay, so every unmentioned subnet to be routed using the default route, okay, and can be a default gateway. So the gateway, which is my next hop, my next step taking from this router, is my gateway, which will be the internet, or maybe it will be the edge router of my company. After that, it will be the edge router of the service provider company that's giving me the internet. Maybe after that, it will be the internet. So my gateway is the edge router of my company. My edge router company gateway will be the service provider edge router, and the service provider edge router default gateway will be the internet itself, okay, so this is the concept of default route. And there will be, and then we have the floating static. The floating static is a hidden backup plan, is that I will mention and maybe some network to some destination, and by using remember this topology that I have drawn so much in the past two videos. Okay, so I will use this path to route 10 dot something, but just in case something went down, you know, static route something manual, it will not do reroute the packet from this way, it will just went down. Then I will type in my routing table in my config route the same network and the same destination using another path, which will be this path. But when you issue the command of show IP route that you will see in the lab, and you will check your routing table, you will see only the main route installed as long as it's function and working. Once it go down, the other one will jump and pop up and show in our routing table as a backup. Okay, this is floating static. I believe we will also configure this in the lab. Okay, so without further talking, I believe we have crossed over 15 minutes of talking about the concept of static route. In the next video, we will jump to the packet tracer using routers now instead of switches, and we will start to config and see the results and verify the static route behavior. Okay, so stay tuned with us for the upcoming video with the implementation. Thank you.